Welcome to the Mahatma Gandhi Institute of Technical Education and Research Center. In 2004, a national level institute MGITER has been started in the field of engineering and technology as per guidelines of All India Council for Technical Education AICTE New Delhi. MGITER is approved by AICTE New Delhi, Gujarat State and affiliated to Gujarat Technological University Ahmedabad, which is also known as GTU. Our goal is to be an institute of generative ideas so that we remain relevant to our society. The MGITER has always been an organization on move with continuous effort on improving its processes and to maintain its relevance to the Indian science scenario, with adding new programs in its programmatic portfolio. We strongly believe in overall development of students, so for that we provide them a different platform like state level tech fest, project fair, different sports activity, which helps students to teach teamwork and problem solving skills to get physical health benefits, boost self esteem, and reduce pressure and stress for prove their skills in distinct area. Welcome to the virtual lecture of Power System Operation and Control. Myself, Professor Gaurang Patel from Mahatma Gandhi Institute of Technical Education and Research Center, NAVSARI. Students, today we are going to learn about your subject Power System Operation and Control in BSEM 7. So before starting the lecture and depth theory of all this subject, I will just want to introduce the syllabus which is designed by Gujarat Technological University for this subject. I will just give you a brief introduction about the syllabus, what are the theories that you are going to be learn in this subject, and how the lecture session will be going on one by one. Okay, the subject code that is given over here that you can see in that is 2180909. Okay, so now the basic aim of the subject is to manage the power which we are producing in our power generation units. Okay, we have the different power generation units that we know throughout this sixth semester of electrical engineering. That are a major power producing units are thermal power station, which is stacked about 75 to 80% of total electricity. Then rest hydroelectricity and nuclear electricity, nuclear power station, and the conventional and non-conventional energy that will produce the remaining of the power. So basic aim of this subject is how to manage those power to send to all the consumers. Okay, so that what we are going to study in that subject. And we know that there is demand of electrical energy is increasing day by day due to improvement in the lifestyle of the people in particular and development of the countries in general. So in the other hand, conventional sources of power generation are limited. At we know that the conventional sources, that is thermal power station, nuclear power station, that sources are quite limited with compared to the non-conventional sources. So under this scenario, the power system network operates in a stressed condition. Okay, because the demand is increasing and each and every day the need of electricity is increasing, so the existing power system is in operating in stressed condition. So it is necessary for optimal system operation for loss minimization and to avoid the unwanted power cuts. Okay, and this subject deals with the fundamentals for effective operation and control of the power system. Here we can see the teaching and examination schemes. There are lectures, theory portions are there, and there is an external exam of 70 marks, and you can see there is a mid-sem exam of 20 and 10 marks. So total marks 100 mark subject, power system operation and control, there is a total 100 mark subject. In the first chapter, that is all about the automatic generation and voltage control. In that subject, there is a load frequency control and load frequency control and economic dispatch control, two area load frequency control, optimal load frequency control, automatic voltage control, load frequency control with generation rate constraints, speed governor, date bandits, effect on AGC, digital LF controllers, decentralized control. So this first chapter is all about automatic generation and voltage control, how the generation are being controlled and how the voltages are being controlled with the automation. That's what we are going to learn in this chapter. So after successfully completing this chapter, we can move towards the second chapter, that is power system security. So its name, it suggested that what inside in this chapter, that power system security, that means how can we optimally transfer the power from one end to the another end of the electric system. Okay, so for that we are erected the transmission line, distribution line. So we must have to operate those power system in that in such a manner that reliability of power can be sustained for each and every time. So power system security is as important as the automatic generation and voltage control. So after completion of power system security chapter, we are moved towards the reactive power and voltage control. So as we know that there are two kinds of power in our power system, that is, one is active power and one is reactive power, that you were known about that in semester third subject. About that subject name was the electric power system, or EPS1. Okay, so in that we have taught about what are the generation, how the generations are happen, and how those generated power transmitted and distributed to the consumers. Okay, and in this chapter, reactive power and voltage control, we are begin with the introduction. Then we will see a reactive power requirement of an uncompensated line, then implication of surge impedance loading, then a reactive loss characteristic of transmission line, then operation of transmission line at no load condition, operation of a transmission line under heavy loading condition, etc. Okay, so then after we will see what is the voltage regulation of the transmission line and what are the parameters which play a significant role for the voltage regulation in transmission line. Then we know the relation with the reactive power. After that, maximum power transfer in an uncompensated line, that is line loadability. Then reactive power voltage, that is a Q and V coupling concept, how that reactive power and voltage are coupling. Then governing effect on reactive power flow. Then after, relation between voltage and reactive power at a node in a power system. Then reactive power requirement for control of voltage in long lines. So that seems after that, operational aspects in reactive power and voltage control, then basic principle of system voltage control, reactive power flow constraints and their implications in loss of voltage, effect of transformer tape changing in the post disturbance period, effect of generator excitation adjustment in the post disturbance period, practical aspects of reactive power flow problem leading to voltage collapse in EHV line. So it seems quite a lengthy chapter with compared to previous two chapters, and it is the percentage weighting, that is 20 to 25. So reactive power and voltage control, it is really an essential part of the power system. What we must know about it, how it is operated and how we can control the reactive power for the better transmitting of the power. Okay, then after we will see the state estimation. This state estimation in that chapter we will begin with the introduction, then LSE, that is least square estimation. Then we see that the basic solution, static state estimation of power system, tracking state estimation of power system, some computational consideration, actional system equivalency, treatment of bad data network, and observability and Pushedo measurements. And also we will see the application of power system state estimation. So that's how our chapter 4 is going on. Then after completion of chapter 4, we will move towards the load forecasting. So in load forecasting chapter, there is an introduction. As usual, we begin with the introduction, then forecasting methodology, then estimation of average and trend terms, estimation of periodic components, estimation of Y of K, time series approach, long term load predictions using economics models, and reactive load forecasting. Okay, so that is the second last chapter, fifth one, that is load forecasting. Then completing this chapter of load forecasting, then we will see the introduction to power system deregulation and restructuring. That is the final chapter of our syllabus, that is introduction to power system deregulation and restructuring. So about this chapter, the deregulation comes into the picture in India. We will see when it comes and what is the impact of deregulation being happen after implementing the rule act in 1973. That we will see how it is affect the whole power system. Then restructuring, that means the new advancement, new automation comes into the picture, and implication of those automation into the industry, so we can get the more reliability of power supply. So in that chapter we can see uh, introduction, then after motivation for restructuring of power system, what is the motive behind that. Then electricity market, how the electricity market is going to be run. Then utilization, market estimates and model, benefits of deregulation, basic terminologies, deregulation, international scenario, milestones of deregulation in the world. Then we will see the Indian power sector, that is past and present status. Then after growth of power sector in India and overview, a timeline of an Indian power sector players in the Indian power sector research and professional bodies. Then there are some of the reference books that can be used to complete our knowledge of this subject. There are 7 or 8, I think there are 8 books are given, and you can see all the name of those books. That is Modern Power System Analysis by D.P. Kothari, an Introduction to Reactive Power Control and Voltage Stability in Power Transmission System by A. Chakrabarti and D.P. Kothari. Then book number 3, that is Electric Power System by P. Venkatesh, B.V. Manikandan and S.C. Raja, S. Srinivasan. Power System Analysis by G. Granger and W.D. Stevenson. Then Power Generation Operation and Control by A.J. Wood and B.F. Woolenberg. And then Power System Analysis by Hadi Sadar, Advanced Power System Analysis and Dynamics by Alp Singh, and Operation of Restructured Power System by K. Bhattacharya. Okay, so these are the books that you can utilize for the completion of this subject. So that's how the syllabus is going on, and you can also use this online NPTEL website for getting further guidance of that subject. Okay, so I hope you understand how the syllabus is going to be completed, and these are the aims that students should be able to understand. That is, understand the techniques to control power flows, frequency and voltage, explore the significance of power system restructuring as we discussed, then perform system state estimation and explore its importance, learn the power system security and its application as a system operator, and carry out load forecasting using available methods. These are the list of open source software and some of the assignments throughout that subject you have to complete it. Okay, so we'll start here with the first chapter of the subject power system operation and control. The first chapter is automatic generation and voltage control. So here you can see that. So before beginning this subject and going further, we will see some of the initial discovery of the electrical system and how the electrical system is going to be work. So we will start with that. That electrical technology was founded on the remarkable discovery by Faraday that a changing magnetic flux creates an electric field. That is, Faraday stated that the changing magnetic flux created an electric field. Okay, and out of that discovery grew the largest and most complex engineering achievement of man. Okay, it's being the largest and most remarkable achievement we can say in the history of engineering. That is the electric power system. Okay, so indeed, life without electricity is now unimaginable. We can see the life without electricity is quite unimaginable. An electric power system forms the basic infrastructure of a country. That we know all the improvement of the industry and all the improvement of our country, that depends on the how much power we can generate, how much electricity we can generate. Okay, so where that we need that electric energy is being produced at rates in excess of hundreds of gigawatts in the world, and giant rotors spinning at speeds up to 3000 rotations per minute bring us the energy stored in the potential energy of water or in fossil fuels. Yet we notice electricity only when the lights go out. Okay, so when there is no electric power is there, then only we can realize how much the essential of that electricity is in our life, that we can only able to understood that. Just a moment. So uh, there was a first complete DC power system built by Edison, that is 1980, sorry, it is 1882, that incandescent lamp supplied by steam driven DC generators, that is electrical cable system at 110 watt, and 59 customers spread over an approximate area of 1.5 kilometer radius. So that is first it is initiated with the DC power system built by Edison, that is in 1882. Okay, so it is initiated with the only 59 customers, and it is initiated with the DC power supply. So after evolution of transformer, and there is a huge change will be take place in electrical power system. So we can see the use of transformer in power system, that is we can see it is a heart of the power system. And with this with the discovery of transformer, this all DC power system switch over to the AC power system due to these those advantages over the DC system. AC systems are become more popular. Okay, and what are the advantages and disadvantages we will discuss in this lecture later. Okay. Then after Nikola Tesla, that polyphase induction motors led to development of AC three-phase system. That is after discovery of is induction motor, that is three-phase induction motor. It's being used, and this three-phase induction motor is a huge part of the industry for the utilization of electricity. Then interconnection of system led to standardization of frequency, because that interconnection, when we make an interconnection of power system, it is necessary that the frequency is going to be managed within the limit, and it should not be uh, varying with respect to time. So we are in different countries, there are different uh, frequency of power system. Like in US that is 60 hertz, in India that is 50 hertz frequency should be maintained in the power system. And use of higher and higher voltage levels and standardization of voltage levels, it's being happen due to the development and the demand of energy is increasing day by day. Then development of mercury arc valves, that is the development of, we can say, the power electronics device comes into the picture. And those due to that the development of power electronic area, there is a HVDC system comes into the picture. Okay, and so till date the development is going to be on and on, and we can see nowadays there are automation comes into the power system, and it plays a major role in power system. So as we discussed about the power system operation, it will be shown that It happened that restructuring and development in power system comes after this law, that is the Electricity Act 2003, is an act of Parliament of India enacted to transform the power sector of India. Okay, and the act covers major issues involving generation, distribution, transmission, and trading in power. While some of the sections have already been enacted and are yielding benefits, there are a few other sections that are yet not to be fully enforced till date. Okay, so before Electricity Act 2003, the Indian electricity sector was guided by the Indian Electricity Act 1910 and the Electricity Supply Act 1945 and the Electricity Regulatory Commission Act 1998. Okay, so the generation, distribution, and transmission were carried out mainly by the state electricity boards in various states, and due to political economic situation, the cross subsidy reached at an unsustainable levels. Okay, so for the purpose of distancing state governments from a tariff determination, the Electricity Regulatory Commission Act was enacted in 1998. So as to reform electricity sector further by participation of private sector and to bring in completion, Electricity Act was enacted in 2003. So here are some of the comparison is given, just a moment, so we can see here, that is the total installed capacity is given. We can see there is a central sector and we can see there is a demand of in megawatt. Central sector, that is required 93,927 megawatt. Then state sector, that is 101 lakh 3617 megawatt, that is percentage of 27% of total, and private sector, that is 1,76,655 megawatt. So these are the total installed capacity till as on 13/11/2020. So these are some of the data that you can. So here there is a data for the total installed capacity as on 13/11/2020. Okay, so this data is important to know because that we can know how much electricity that we are going to be generated nowadays. Okay, so now you can see over here, these are the different sources from that we can produce the power. That is coal, that is producing 1,99,595 megawatt. Okay, so it is a part of total thermal energy, coal, lignite, gas and diesel. And as we know that 61% of total energy requirement that we needed, that is produced by the thermal energy. Then after comes into the picture that hydro and renewable, that is 12% of the total contribution in that. Then nuclear having a light amount, that is 1.8%, and in megawatt if you can see, that is 6780 megawatt. Okay, and you can see that is RES, that is renewable energy sector, that is 90,399 megawatt, that is 24.2 megawatt. Okay, so that's how the total 3,74,199 megawatt energy is going to be produced as per the data. Okay, so here there is also some of the data you can see, that is total generation and growth over previous year in the country during 2009 to the 2020. So we can see in 2009 to 10 there is including renewable sources, and that is a percentage of growth of electricity. So 808.498 billion unit, that is a BU, that means the billion unit. 808.498 billion unit we are going to generate it in 2009-10. Okay, so it is increasing with the growth of 5, 9, 4, 5, 8, 5, 5, 5%, average 5 to 6% during the last decade. Okay, and in contrary side, in 2020-21, it is you can see it is in growth is quite decline. Okay, and due to the reason of that, we know that the pandemic situation due to the COVID-19 year in last year, we can see that there is a little bit sorry, not a little bit, there is a major decline of that percentage of growth. Okay, and I hope it will be covered soon. So the PLF, that is plant load factor, is the data of plant load factor, and that PLF is the ratio of average power generated by the plant to the maximum power that could have been generated in a given time. So more PLF results in more revenues and lesser will be cost per unit energy generated. These are all the data that power supply position in the country during 2010 to 2021. Okay, so you can see here that is the requirement and that is the availability. In 2009 to 10, there is a requirement of 8,30,594 mega unit, and we produced 7,46,644 mega unit. So that is in minus 82,950 mega units. So from this data you can see this gap are decreasing day by day, because it is minus 89,950 mega unit that decreasing in 2019-20, that is only 6,566, and 2020-20 it is minus 2,735 megawatts. So it shows the progress of power system network that every year we install a new power system to generate the more power for the country. Okay, so next, that is the generation of billion units, as we shown in the previous graph. In 2009 and 10, there is 805 billion units are there, and in 2019-20 it 13,800 and 1389, that is 1389 billion units producing in 2019-20. So from that we can see how much electricity demand will be increasing year by year, and for that we must have to produce that electricity to reach or fulfill this demand. Okay, so there is also a growth in total generation percentage. Then we can see some introductory part, that is in an interconnected power system where number generators run in parallel. Okay, so just a moment. So we can say in an interconnected power system where numbers just a minute, okay, where number of generators runs in parallel. So in interconnected system there are a number of generators in runs in parallel, and the different generators in the system may be running at different speed depending on the number of poles. Okay, and the third point, that is says that the hydroelectric power generators operate at much lower speed compared to steam turbine driven generator. That is, hydroelectric power generators operate at much lower speed compared to the steam turbine driven generator. Then fourth one, that is, but all generators have same electrical speed, means system frequency remains constant. So same speed, that means your frequency should remain constant, and if system frequency is constant, it means that the system generation is balanced with load demands. Okay, so also we have to consider that in a power system the load demand is continuously changing. As we know that demanding load is not in our hand, it is changing continuously. Either you can see in the morning there is power demand is something different, in mid of the day it is varied, and at the end of the day it is also, you can see, it is varied. Okay, so in accordance with the power input also varies. If the input output balance is not maintained, a change in frequency will occur. So that frequency control is important in interconnected power system. That we know that input output, if we don't maintain that input output ratio, that frequency is going to be changed. That so that we must be maintain those things. And fourth point, that is says that the frequency of control is achieved through a speed governor mechanism. How the speed governor mechanism is worked, how the transfer function play into role for the speed governor mechanism, that we will see in the lecture. So the role of governor is to control the relation between the speed and load, and if the load on the turbine increase, the speed of the governor decreases. So the frequency normally varies by 3% between light and full load condition. Here you can see that is a diagram. You can see that for the balanced grid service, it not be more than 5% changes are desirable. This is the electrical generation, and this side is the electricity demand. So our electricity should remain constant at the 50 hertz part to balance the grid services. Okay, so finally, just I would like to give you a message. Please remember the electric switch when it's not required. When it's not required any need of electricity, please turn off the switch and save the electricity, save the world. Okay, thank you very much for attending my lectures. Thank you.